Welcome to another video on OpenShift, and in this video I will talk about how to create a very simple application and create an image for it and push it to an image repository like Docker Hub, and how to consume it in OpenShift. So let's get started. So here is my application that I developed to implement Karatsuba algorithm. So what is Karatsuba algorithm? It is a popular one to multiply numbers, but what's the big deal in multiplying numbers? The computer should be able to do it natively. However, if the numbers are really long, how do you do that with native computer science? Like a variable in a programming language will not be able to handle that, except Python or some similar programming languages. So here is the algorithm, Karatsuba algorithm, and you can go to wiki to understand it more. So I'm not going to explain what this algorithm does, but I will show you an implementation and how to build it using a makefile. And then we're going to see something interesting. We are not going to invoke the makefile on my compute environment. I'm going to use what is called Travis CI to build it. And while building, the built image can be copied over to an image repository like a Docker Hub or Quay or whatever image repository that you would like. So let's get started. Here is the source code, the C++ source code. Let me look at the final implementation. Here is the main method that multiplies two really long numbers. And you won't be able to do this in a C++ program natively. And in Python you can do it. You can just say variable number 1 equal to such a big number and then so on. Python, I understand, implemented the same Karatsuba algorithm to multiply two numbers. So that is the popularity of this algorithm. So this main method invokes a function called Karatsuba, and the Karatsuba is described here, which uses the recursion algorithm to divide the number, treat the number in the form of a string first of all, and then divide the number into half and then half and half and half, and then multiply them and then assemble the results back. You should be able to Google Karatsuba algorithm and then get more information. Anyway, here is the entire implementation. I'm not going to go through this here, but let's look at the makefile used to build it. So here it is. It has several sections, and here is the final paragraph to build an executable. If I would do it on my Mac, I would clone this GitHub page repository, and then I would simply run make, and that will build the Karatsuba executable. And if I run Karatsuba, it should show me the final output, the multiplied number of two really long numbers. But there are some additional sections added here in this makefile. One is to build the image using Docker build. The second is to build an image tar file. That is what Docker build does. And then, the save image does, the Docker save. And then the Docker push will push it to the image repository that I set it up. I'm going to use the Docker Hub. I have a repository called svenkat.doc, and under that I'm going to create an image called Karatsuba with the version 0.0.1, and this push image will push the final image into the Docker Hub. So I want to show you one more tiny thing about this application. Going back to the main method again, after printing the output, this application sets itself in an infinite loop. There's a reason behind that. I want the application to be running so that I can look at the output in the OpenShift or Kubernetes environment later on. Okay, So now, as I said earlier, I'm not going to run this make file. I want Travis CI to run this make file and invoke the make file in such a way that it not only builds it, but also build an image for it and then saves it somewhere and then pushes it to the image repository, Docker Hub in my case. So how do we do that? In a GitHub repository, create a file called .travis.yml. And if you do that, the Travis CI will automatically pick up this source code and then build whatever rules that you define in this Travis.yml file. And not only that, whenever you make any changes to any of the files in this repository, the Travis will build it for you. That is as cool as that. So now let's take a look at this Travis.yml file. It is .travis.yml. That is more important. It's a very tiny file, and I'm asking Travis CI to build this executable on x86-64 Intel processor platform. And the language used is C++, and the compiler used is G++, the GNU G++. And I want the Ubuntu toolchain, because Travis CI will use a Ubuntu VM to run this building. So I want the Ubuntu toolchain and the whatever that is needed to build a C++ executable. And finally, I'm going to be making a Docker login and then Docker push, the Docker push. So now let's take a look at the Docker login in the make file. So let's go back to make file. And as you can see in the Docker build, it requires an username and password for the Docker Hub so that the image can be pushed into the Docker Hub. So that is defined here. The Docker login happens at the very early stage of this make file, and it uses a couple of environment variables called Docker username and Docker password. So if I would do it on my Mac before running this make file, I would set these environment variables, Docker username and Docker password. And then if I run this make file with the push image as the parameter, then the the make file, the make program will not only build it but also push it to Docker Hub using this Docker login. So how do I do this through Travis CI? The Travis CI is supposed to do this automatically for me. So that is done in a bit differently. So I'm going to show you the Travis CI page corresponding to this repository, and here it is, travisci.org, and I created this Karatsuba. I imported this Karatsuba application from GitHub into Travis CI. So from this application defined in Travis CI, I'm going to go to the more options and click on settings, and I can see the environment variables here. So I set up these two environment variables with appropriate values, my Docker username and my Docker password. So this is how you pass the environment variables into the Travis CI. So by the time Travis CI executes this make file, it will have the username and password in it. So here is one such execution already. It's been building so many times. So it automatically starts the build. It creates a Ubuntu VM, and then it follows all the instructions that I gave in the Travis YAML file, and finally built it and pushed it into the Docker Hub. So now I'm going to show you how it looks in the Docker Hub. So here it is. So under repositories, there is a Karatsuba image already created, And if I want, I can do a Docker push, or I can Docker pull to consume this image. So these are the tags that I created, 0.0.1, and that information came from the makefile, the image version, and that image version is specified when I do the Docker push. Okay, so now let us see how to consume this image in an OpenShift environment. Oh, I wanted to show you the Docker file. Nothing fancy in it. This is the Red Hat 8.0 image, and the executable is copied over to the root of this file system, and it is made as an executable with chmod, and then it installs all the runtime requirements for executing a C++ built application. And finally, when the image is instantiated in a Docker environment or an OpenShift environment, container environment, it executes the Karatsuba application. This is more important. Okay. Now let me log into my OpenShift environment. This is OpenShift environment, and I'm going to bring in this newly built Karatsuba image and execute it. So let me do that by going to developer. So in the developer view, let me go and click add, and then go to the container image, and I'm going to key in the image as svenkat doc Karatsuba with version 0.0.1. Let me search for it, and I should find it in Docker Hub. So OpenShift will by default go to Docker Hub and find this image. And I do not want to create a route for this application because this is not a web application. And I picked deployment versus deployment config because I want to deploy a pod immediately. I don't want to create a deployment config and then deploy the application pod later. That is not my intention. So now let me click on create. So the application is now created. Let me go back to the administrator view, go to workloads, pods. So here is the pod that got created by the deployment. Let me show you the deployment as well. This is the deployment I created from the previous page, and this deployment created the application pod. And here is the pod. So now let me click on this pod and look at the terminal, and I should be able to enter inside the terminal of this pod. And here is the Karatsuba application in it, and there's no PS, but the application is running. So let me look into the logs. There it is. This is the answer. This is the multiplication answer for the two really long numbers we saw earlier, and the application is still running because there is an infinite for loop in the main method of the application. So this is how you build an image using GitHub and Travis CI and push it to an image repository like Docker Hub, and this is how you consume it in a Kubernetes or OpenShift environment. Hope you enjoyed this video. I will be producing a lot more videos on OpenShift, and have a wonderful day. Bye for now.